Now let us refer activity 12.3. From this activity, we will learn factors on which the resistance of a conductor depends. So let us see. You will refer to page number 206 in your textbook. Refer to figure 12.5. We have to set up an electric circuit which consists of a cell. Here it is not a battery, it is a cell. An ammeter. For what do we have to use ammeter? Because it measures an electric current flowing through the circuit. Then we have to use a nichrome wire of length L, say marked 1, and a plug key as shown in the figure. Now in the figure you can see there are numbers written 1, 2, 3, 4 for different lengths of a wire. Let me explain you what it is. Look into the figure where it is written 1. That is a nichrome wire of length L. Okay, number 2, that is again a nichrome wire, but the length is double, which you have taken before. That means the length in second one will be 2L. It is double than the first one. Third is again it is a nichrome wire, but thicker wire than before. Thicker. And fourth one, that is instead of nichrome wire they have taken a copper wire. So this all are 4 different types of wires. What do we have to do? First of all, we have to place only one wire, which is a nichrome wire, where it is written number 1. That means it is a nichrome wire of length L. Others wires we don't have to attach. Firstly, only one wire, nichrome wire of length L. Then we have to put a plug key. That means we have to switch on the circuit. Then we have to note the reading from ammeter, which will show the current flowing through it. In second case, we have to remove this nichrome wire of length L and we have to place a nichrome wire of double length. That means in the number 2 which is given, that is length 2L. And then we have to note the reading. In third case, we have to remove this 2L nichrome wire and we have to keep a thicker wire which is thick than before, and then to note down the reading. In the fourth case, we have to remove all these wires and we have to keep a wire of length L, but it is a copper wire. Then we have to note down the readings. Then we have to notice the difference for all the cases. From this activity, we will observe that the ammeter reading decreases to 1/2 when the length of wire is doubled. This means in the first case, for example, we got ammeter reading current as I, that is electric current I, when the length of the wire was L. So in second case, when we doubled the length of the wire, that was 2L, then the ammeter reading was half. So I will become I by 2. I divide by 2. In the first case, reading was I. So in the next case, when we doubled the length of the wire, it became half. So we got I by 2. So it says that the current decreases when we increase the length of the wire. In the third case, when we used a thicker wire of the same material, it was nichrome only, but we used thicker wire. So when we used thicker wire than before, then I has increased. That means electric current has increased before which we got. And in the last case, when we used copper wire, at that time also it shows different ammeter reading than the nichrome wire. From all these 4 cases, what can we conclude? We can conclude that it shows different ammeter readings. That means different electric current for different lengths of wire and for different materials. So by applying Ohm's law, we observe that the resistance of the conductor depends on, this is very important factors you need to remember what it is. The resistance of the conductor depends on, first thing, on its length. We just saw from the activity, on its area of cross section, and on the nature of its material. So from all these cases in the activity 12.3, we concluded these three factors which you need to remember. So resistance depends on length, area of cross section, and the nature of material. Now, what is this area of cross section of a wire? I'm sure you have heard the word cross section. Here in this area of cross section of a wire is that when you cut a wire widthwise, that means when we cut a wire, at the ends of the wire we can see circular structure. When we cut it, at the end we can see circular structure. So that is called area of cross section. The area of that circle will be known as area of cross section. What is cross section? When we cut anything directly, we can see the ends of it, which will be seen as circles. So here the resistance depends on area of cross section also. You can note that when we used a copper wire in case 4, that time it was having same cross section as that of nichrome wire. This means both will have same width. When we cut both the wires and at the ends we see the circles, the area of that circles for both the wires will be same. That means their widths will be same width. Okay, now there's three factors you will remember on which the resistance depends. Now look at the equations which are written. R is proportional to L, which we have concluded from this activity that we are writing in terms of formulas and equations. R is proportional to L, which is length. So resistance is proportional to L. And it is inversely proportional to area of cross section. See in equation 12.9. R is proportional to 1 divided by A. That means 1 divided by area of cross section. This means R is inversely proportional to area of cross section. Why it is written inversely? Now see equation 12.A, which is R proportional to L. This means when we have increased the length of the wire, what we got it as? We got that ammeter will give decrease in the reading. That means electric current decreases. And from Ohm's law, we know that electric current and resistance both are in inverse proportion. So here what will it become? R is proportional to L. This means when we increase length, resistance will increase. When we decrease the length, resistance will also decrease. So R is proportional to L. Now equation 12.9, R is inversely proportional to 1 divided by A. That is R is inversely proportional to area, which means if area increases, resistance decreases. If area decreases, resistance increases. From this equation, R proportional to 1 divided by A, to remove this proportionality sign, we will keep a constant that we all know, and here the constant is rho. In equation 12.10, you can see it is written as R is equal to rho into 1 divided by A. how to pronounce it as rho. What is rho? It is a constant of proportionality and it is called electrical resistivity of the material of the conductor. Please remember this. Rho is a constant of proportionality and it is called electrical resistivity. The SI unit of resistivity is ohm into meter. How did we get ohm into meter? It is already taught you in standard 9 how to find SI unit. If we want to find SI unit of rho from equation 12.10, how can we write? Rho will be equal to R into A. R is resistance, A is area. Unit of R resistance is ohm and unit of area is meter. So unit of electrical resistivity becomes ohm into meter. Okay, unit of resistivity becomes ohm into meter. It is a characteristic property of the material. The metals and alloys have very low resistivity in the range of 10 raised to minus 8 ohm into meter to 10 raised to minus 6 ohm into meter. They are good conductors of electricity. This means when they are good conductor of electricity, what does that mean? We have already learned through previous activity. When they are good conductor of electricity, this means they provide low resistance. Okay, so they will have less resistivity. Insulators like rubber and glass have resistivity in the order of 10 raised to 12 to 20 raised to 7 ohm into meter. Both the resistance and resistivity of a material vary with the temperature. There is a table 12.2, which gives different electrical resistivity of some substances at 20 degrees Celsius. So from this table 12.2, we can say that the resistivity of an alloy is generally higher than that of its constituent metals. For example, we know that alloys are combination of metals, right? Now, what we can see from this table, that the components of conductors will have less resistivity than the alloys. For example, in number 1, for different conductors, silver, copper, aluminum, tungsten, nickel, the resistivities are given. Look at the resistivity of copper, which is 1.62 into 10 raised to minus 8. See the resistivity of nickel, which is 6.84 into 10 raised to minus 8. Now, look at the resistivity of alloys. In the first one, you see constantan, which is alloy of copper and nickel. What is its resistivity? It is 49 into 10 raised to minus 6. What do we observe? What can we conclude from this? When they were individual conductors, their resistivity was less. One was 1.62, another one was 6.84. Now when they have combined and they formed alloy, their resistivity becomes 49 into 10 raised to minus 6. That means it increases. So we can say that the resistivity of an alloy is generally higher than that of its constituent metals. Alloys do not oxide. Alloys do not oxidize, which means they do not burn readily at high temperature, and that is why they are commonly used as electrical heating device like electric irons, toaster, etc. Alloys, which are combination of metals, they do not burn easily, and that is why alloys are used for electrical devices, electrical heating devices, for example toaster, electric irons, etc. Tungsten is used almost exclusively for filaments of the electric bulbs. What is a filament? I'm sure you all have seen a thin metal wire in an electric bulb. which transfer electrical energy to light energy, and as a result the bulb glows. So filament is a thin wire in the bulb. So tungsten is used almost exclusively for filaments of electric bulbs. That means for making filament, tungsten is used, whereas copper and aluminium are generally used for electrical transmission lines. We have seen that there are copper wires and aluminium wires for passing electrical current. So, this is all about factors on which the resistance of a conductor depends. Now, the values given in table 12.2, you don't need to remember the values. We will use this value for doing numerical sums. When it will be asked in the sum, the values will be given. So, you don't need to remember all this value. So, this is all about today's session. Thank you.